Chapter 20, Section 1, Interactive Reader, pages 295 through 300, 20 points. Water in the atmosphere, atmospheric moisture. Key ideas. As you read this section, keep these questions in mind. How does energy affect the changing forms of water? What are absolute and relative humidity, and how are they measured? What happens when the temperature of air decreases to the dew point? Page 295. What happens when molecules in liquid water absorb energy? Is heat released or absorbed when ice melts? How does water change phases? Highlight. Water can exist in 3 different phases or states. Continue highlighting. The gas phase is called water vapor. Continue highlighting. The solid phase is called ice. Continue highlighting. The liquid phase is just called water. Water changes phases when it absorbs or loses heat energy. For example, molecules of ice move very little and are packed together tightly. When the ice absorbs energy, the molecules begin to move more quickly. They break out of their positions and slide past each other. The ice melts and becomes liquid water. Highlight. When water absorbs more energy, the molecules move even more quickly. Continue highlighting. The molecules that move the fastest escape from the liquid in a process called evaporation. Continue highlighting. When the water evaporates, it changes to water vapor. Question 1. What happens when molecules in liquid water absorb energy? Answer. Move faster, escape from liquid, and become water vapor. Again, move faster, escape from liquid, and become water vapor. Latent heat. Highlight. Latent heat is the heat that is absorbed or released by a substance when it changes phase. For example, when water vapor condenses or changes into a liquid, energy is released. This energy is latent heat. Highlight. Similarly, latent heat is absorbed when ice thaws and is released when water freezes. Next to the diagram, water exists in 3 states or phases. As it changes from one phase to another, water either absorbs or releases heat energy. As you're looking at the diagram, notice that the ice, the solid on the left, heat is absorbed when it converts to water vapor. When water vapor, a gas, changes to ice, heat is released. When water vapor, a gas, changes to liquid water, heat is released. When liquid water is converted to a vapor, heat is absorbed. When liquid water is changed to ice, heat is released. When ice is changed to liquid water, heat is absorbed. Question 2. Is heat released or absorbed when ice melts? Answer would be absorbed. Absorbed. Page 296. How does most water enter the atmosphere? How is sublimation different from evaporation? What will happen to some of the water vapor in the second figure? Evaporation and sublimation. Highlight, most water enters the atmosphere through evaporation. Continue highlighting. The oceans near the equator receive a lot of solar energy. Therefore, highlight, a lot of water in those oceans evaporates into the atmosphere. Continue highlighting. Most of the water vapor in the atmosphere comes from the oceans. Question 3. How does most water enter the atmosphere? Evaporation of water from the oceans. Evaporation of water from the oceans. Water vapor also enters the atmosphere from lakes, ponds, streams, and soil. Highlight, plants release water into the atmosphere through the process called transpiration. Continue highlighting. Animals give off water vapor when they breathe out. Continue highlighting. Volcanoes and burning fuels also release small amounts of water vapor into the atmosphere. Usually, ice changes to a liquid before it turns to water vapor. However, highlight, sometimes the ice changes directly to water vapor without becoming a liquid. Continue highlighting. This process is called sublimation. Sublimation generally happens when the air is dry and the temperature is below freezing. How is sublimation different from evaporation? Ice, not liquid water. Ice, not liquid water, changes to water vapor. Changes to water vapor. Again, ice, not liquid water, changes to water vapor. What is humidity? Highlight. The water vapor in the air is called humidity. Continue highlighting. Humidity is controlled by the rate of condensation and the rate of evaporation. Continue highlighting. The rate of condensation is a measure of how quickly water vapor condenses. Continue highlighting. The rate of evaporation is a measure of how quickly liquid water evaporates. Continue highlighting. The temperature of the air determines the rate of evaporation. Water evaporates faster at higher temperatures. Highlight. The rate of condensation is determined by water vapor pressure, as the figure below shows. Continue highlighting. Vapor pressure is the pressure that water vapor in the air puts on an object. When vapor pressure is high, the rate of condensation is high. On the left, no vapor pressure, water at the bottom, dry air in the middle, 20 degrees Celsius. On the right, increased vapor pressure, water at the bottom, water vapor in the bottle, 20 degrees Celsius. Under the diagram, when water comes into contact with dry air, some of the water molecules evaporate. The water vapor in the air creates vapor pressure. Highlight. The vapor pressure causes some water vapor to condense and become liquid water again. Question 5. What will happen to some of the water vapor in the second figure? It will condense. It will condense. Page 297. Why did the air condense when it touched the spider web? In 2 cubic meters of air, there is 30 grams of water vapor. What is the absolute humidity of the air? The dew point. Highlight. When the rate of condensation equals the rate of evaporation, the air is saturated with water vapor. Continue highlighting. The temperature at which the air is saturated is called the dew point. Continue highlighting. Air can cool below its dew point when it touches a cold surface. For example, grass, leaves, and other objects near the ground lose heat at night. Their surface temperatures drop. When air comes into contact with these objects, it cools. It can cool enough to reach its dew point. At temperatures below the dew point, liquid water droplets can form from the water in the air. When air comes into contact with cool grass, it can reach its dew point. If it does, liquid water droplets form on the grass from the vapor in the air. Highlight. These droplets are called dew. Under the diagram, the dew on this spider web formed when the air dropped below the dew point. Continue highlighting. If the dew point falls below the freezing temperature of water, frost may form. Continue highlighting. Frost is when water vapor that changes directly into solid ice. Frost is not frozen dew. Unlike frost, frozen dew looks like clear beads of ice. Frozen dew is very uncommon. Question 6. Why did the air condense when it touched the spider web? The web was cooler than the dew point. The web was cooler than the dew point, lowering the air temperature below the dew point. Lowering the air temperature below the dew point. Again, the web was cooler than the dew point, lowering the air temperature below the dew point. Absolute humidity. Highlight. One way to express the amount of moisture in the air is by calculating absolute humidity. Continue highlighting. Absolute humidity is a measure of the actual amount of water vapor in the air. You can calculate absolute humidity using the following equation. Highlight. Absolute humidity equals mass of water vapor, grams, divided by volume of air, cubic centimeters. Question 7. In 2 cubic meters of air, there is 15 grams of water vapor. What is the absolute humidity of the air? Divide 15 by 30. 15 divided by 30. I'm sorry. Divide 30 by 2. Divide 30 by 2. Your answer is going to be 15 grams per cubic meter. That's where I got the 15. 15 grams per cubic meter. So divide 30 by 2. You're dividing the mass by the volume. Your answer should be 15 grams per cubic meter. Why do scientists often express humidity as a mixing ratio rather than as absolute humidity? If 1 kilogram of air at 25 degrees Celsius contains 25 grams of water vapor, what is the relative humidity of the air? Mixing ratio. Highlight. Absolute humidity depends on the volume of air. Continue highlighting. When the temperature or pressure of air changes, its volume can also change. Continue highlighting. Its mass, however, does not change. Therefore, meteorologists prefer to express the moisture in air by using the mixing ratio. Highlight. The mixing ratio is the ratio of the mass of water vapor to the mass of dry air. For example, the air in moist regions might have 18 grams of water vapor in 1 kilogram of air. Therefore, the mixing ratio would be 18 grams per kilogram. Highlight. Because the mixing ratio uses only units of mass, it is not affected by the temperature or pressure changes. Question 8. Why do scientists often express humidity as mixing ratio rather than absolute humidity? Answer. Because it uses only units of mass. Because it uses only units of mass. It is not affected by temperature or pressure changes. It is not affected by temperature or pressure changes. Again, because it uses only units of mass, it is not affected by temperature or pressure changes. Relative humidity. Highlight. Scientists also express the amount of water vapor in the air by measuring relative humidity. To calculate relative humidity, highlight, scientists first measured the amount of water vapor in the air. Continue highlighting. Then they determined the amount of water vapor necessary to reach saturation. Continue highlighting. Relative humidity is the ratio of those two numbers. Continue highlighting. For example, at 25 degrees Celsius, air is saturated when it contains 20 grams of water vapor per 1 kilogram of air. If air that is 25 degrees Celsius contains 5 grams of water vapor per 1 kilogram of air, the relative humidity is 5 divided by 20, or 25%. Question number 9. If 1 kilogram of air at 25 degrees Celsius contains 10 grams of water vapor, what is the relative humidity of the air? Set your problem up as 10 divided by 20 10 divided by 20 equals 0.5 equals 0.5 multiply 0.5 times 100 multiply 0.5 times 100, your answer is 50%. 50%. How do meteorologists measure humidity? Meteorologists can use humidity measurements to predict weather conditions. Highlight, they can measure relative humidity using any of these instruments. Continue highlighting. An electrical hygrometer. Continue highlighting. A psychrometer. Highlight a dew cell. Highlight a hair hygrometer. An electrical hygrometer uses a thin film to measure humidity. The humidity in the surrounding air affects the film's ability to absorb or release water vapor. The amount of water vapor in the film affects the film's ability to conduct electricity. Scientists can measure the film's ability to conduct electricity. They can then use those measurements to figure out the humidity of the air. Psychrometer. Highlight a psychrometer. Page 299. Why is the wet bulb thermometer in a psychrometer cooler than the dry bulb thermometer? Label the wet bulb thermometer and the dry bulb thermometer. Psychrometer. Highlight. A psychrometer also measures humidity. Continue highlighting. It contains two thermometers. Continue highlighting. The bulb of one thermometer is covered with a wet cloth. Continue highlighting. The other thermometer bulb is dry. Continue highlighting. As air passes through the wet bulb thermometer, some water in the cloth evaporates. Continue highlighting. Evaporation requires energy, so heat energy is released and the cloth cools. Continue highlighting. The wet bulb thermometer shows the cloth's temperature. If humidity is low, highlight, the water evaporates more quickly. Continue highlighting. Therefore, the temperature reading on the wet bulb thermometer is much lower than the reading on the dry bulb thermometer. Continue highlighting. If the air is saturated, no water evaporates. Continue highlighting. Therefore, the temperatures are the same. Question 10. Why is the wet bulb thermometer in a psychrometer cooler than the dry bulb thermometer? Answer. Water evaporates from the cloth. Water evaporates from the cloth, causing the cloth to be cooler. Causing the cloth to be cooler. The thermometer reads the cloth temperature. The thermometer reads the cloth temperature. Again, water evaporates from the cloth, causing the cloth to be cooler. The thermometer reads the cloth temperature. Question 11. Label the wet bulb thermometer and the dry bulb thermometer. Highlight the tip of the thermometer on the top where the cloth is and label that thermometer wet in the picture. Wet. Label the bottom thermometer dry, next to the person's hand. Label the one next to the person's hand dry. Under the picture, a psychrometer measures the difference in temperature between a wet bulb and a dry bulb thermometer. The measurement can be used to calculate humidity. Other methods for measuring humidity. The table below describes other instruments that scientists use to measure humidity. Dew cell uses electrical resistance to determine the dew point. Hair hygrometer uses a hair to measure humidity. High humidity makes the hair longer. Scientists can use electrical hygrometers to measure humidity high in the atmosphere. Highlight. Scientists attach the hygrometer to a weather balloon. Continue highlighting. The balloon carries the hygrometer high into the air. Page 300. What is the difference between absolute humidity and relative humidity? What happens when the temperature of air decreases below the dew point? What are 4 instruments that scientists use to measure humidity? Name 2 phase changes of water that involve the release of heat. Complete the table below to summarize processes that affect water vapor in the air. Use the terms condensation, evaporation, and temperature to complete the table. In general, the cooler the air is, the less water vapor it must contain to be saturated. What will most likely happen to the relative humidity if air temperature decreases but no water vapor enters or leaves the air? Question 1. Answer can be found on pages 297 and 298. Absolute is the amount of vapor the air holds. Absolute is the amount of vapor the air holds. Relative is a ratio of how much the air holds. Relative is a ratio of how much the air holds to how much it can hold. To how much it can hold. Question number 2. Answer can be found on page 297. Water condenses. Water condenses. Question 3. Answer can be found on page 298. Electrical hygrometer. Electrical hygrometer. Psychrometer. Psychrometer. Dew cell. Dew cell. And hair hygrometer. And hair hygrometer. Again, electrical hygrometer, psychrometer, dew cell, and hair hygrometer. Question number 4. Answer can be found on page 295. Condensation and freezing. Condensation and freezing. Question number 5, worth 4 points. If vapor pressure increases, then the rate of condensation, top right box, increases. If vapor pressure increases, then rate of condensation, top right box, increases. Second box on the left, if the temperature decreases, rate of evaporation decreases. If temperature decreases, then rate of evaporation decreases. Third box on the left, if rate of evaporation is greater than rate of condensation, then evaporation occurs. Again, third box on the left, if rate of evaporation is greater than rate of condensation, then evaporation occurs. Fourth box on the right, if the rate of condensation is greater than the rate of evaporation, then condensation occurs. Again, if the rate of condensation is greater than the rate of evaporation, then condensation occurs. Question number 6. Answer: it will increase. It will increase.